AP reminders. But for right now, let's just get into number 11. Exponential and logarithmic functions. Questions. All right, what do you guys got? Number 11? Okay, let's just go there. Oh, number 5. Oops, those are examples. Sorry, let's get to the actual multiple choice. We'll stop by on number 5, headed on our way to number 11, and you guys have other questions ready if you can. Someone who doesn't know how to do number 5, because some of you have figured it out already. Someone who doesn't know how to do number 5. What do you see when you see this integral? What do you see? I mean, it can be anything. You can see a dx, so everything's in terms of x. You can see a fraction. There's a top and a bottom. What does your brain think? Just help me out, because to be honest, my brain sees it and knows how to do it. U sub? Yeah, I agree. Some sort of U sub is necessary. Some sort of U sub is necessary. What's one thing that we could choose for you? Yeah. We could choose 1 over x. Can anybody figure out what the other u is that someone might try? There are probably 3 u's people could try. 1 over x is 1. X squared is 1. And then e to the 1 over x is another. Those are the 3 different u's that people could choose. Why would choosing x squared not be a good idea? Yeah, you have a 2x dx, and some of you hopefully are getting better and better and better at either showing work or doing the work in your head. And is anything gonna... No. And even integration on crack, if I was to try to solve and put in something nasty to that, it just makes this exponential function harder. So x squared, I have 3 options. That one's bad. X squared's bad. I have 2 options. What if I made u e to the 1 over x? What would du be? Good. E to the 1 over x times? Careful. Derivative of u. You were integrating. The derivative of 1 over x. The derivative of x to the negative 1. Bring down the negative 1. Make it a negative 2. Wait. X squared is a part of the derivative of... Now we could try to solve, and if we did try to solve, we would get dx is equal to negative x squared du all over e to the 1 over x. Wait, what? Everything cancels? Why does everything cancel? Well, I can go ahead and plug in. I would technically say, well, e to the 1 over x is u. But if you guys notice, if we just multiply, not even negative 1, because the u and the u would cancel. And so then my answer would be negative u plus c, and who is u? Technically, this u sub works, but what other u sub would have worked? What Austin said. This would have worked also, as long as you remembered x to the negative 1 to derive it, you need power rule, not integrate to derive. Bring down the negative 1, x to the negative 2. Remember, that's the same thing as 1 over x squared dx. So all that this showed me was that, yeah, choosing 1 over x was a great idea because it totally does work. When I go to plug in, I would have e to the u over x squared times negative x squared du. So the simpler way for most people to do it would have been, this is multiplication, so this is like a negative 1. So it would be negative e to the u du. And what's the integral of e to the u du? E to the u. And who was your u? 1 over x. So whether you do it this way or whether you do it that way, it works out either way. It works out either way. Now, hold on. Where's the plus c? Ah, it's gone. They're wrong. Pause. What's the wording? Could be. Could be. So if they did have this form, the only one that I see that has a negative e to the 1 over x is this one, and they just chose the c to be 0. So yeah, could be. Does that make sense? Nice. Okay, moving on. Let's go down to number 11, and then if you guys have something, we can come back. Number 11, the half-life. Ooh, the half-life of a substance. The half-life of a substance can be modeled using the law of exponential decay. If the half-life of the substance is 10.86 days, how long will it take for 80% of the substance to decay? Now, To be totally honest, I haven't seen one of these on the actual AP, but it's a very typical calculus problem. We did it exponential growth and decay a little while ago. It was that yellow box that we never highlighted, never made a forever card. So it's a little rough, unless you guys remember the exponential decay equation, which is y equals c e to the kt. Technically, there's a negative in there, but we'll kind of just get the negative just by solving the problem. What's something that we can plug in? The ratio. We can say that y over c, remember this one is the, for exponential growth and decay, it's the initial, and this is the after time t amount. So the ratio of this guy to that guy is going to be 1/2, or 0.5. And if I need to divide the c, what's left? Just e to the kt. And t is my time, which is 10.86 days. If I solve this with some pretty simple algebra, taking ln of both sides, technically all three, I would end up with ln of 1/2 is equal to 10.86 k. So k is equal to ln of 1/2 all over 10.86. Once we have k, wait, 80%. Is that a ratio again? Isn't 80% a ratio? Couldn't I make 80%? Wait a minute, is 80% how much is gone or how much is left? Okay, so if 80% has decayed, how much is left? 20%, or 1/5 is left. So now I'm going to set, instead of 1/2 being the ratio, I'm going to set 1/5 equal to e to the, hey, I know k. K is going to be my ln of 1/2 all over 10.86 times, I don't know t. So 80% gone, 20% is left. Percent is 1/5, so I set the ratio equal to 1/5. I can still solve using ln to cancel out my e. And I can end up with t is equal to ln of 1/5. Your calculator can handle this. All over. Ugh.
Yeah, you have to use your calculator.
You have to use your calculator. Sorry, this should be a GC. Please go ahead and put GC on there. Yeah. Well, actually, no. No, not really.
Yeah, I don't know the value off the top of my head. Well, 1/5, and I can't divide by 10.86.
You can do ln of 1 minus ln of 5. You can do ln of 1 minus ln of 2. The ln of 1s would be zeros. But then the problem is you have ln of 5 and ln of 2, and that's going to be pretty approximate. Yeah. I was looking at the answers thinking that it might be easier, but it's not that great. It's not that great. Other questions on multiple choice, evens or odds technically? We're good? Okay, FRQs. Did you guys, when you were doing the multiple choice, did you find any places that you make mistakes on exponentials and logarithms? Log rules, yeah.
I'll get the right, or I'll do all the right work, and then we'll get to like what e to the 0 is, and I'm confused.
Yeah. Yeah, because like, well, even simple things like ln of 1, I mean, they're supposed to be simple, but yeah, we can make mistakes on all these weird things, right? Or if we had something like ln of 2 minus ln of, I guess that's not a great example, like ln of 4 minus ln of 2, and then the answer does something like ln of 2, and you're like, that's not possible, but it is because there's that quotient property. And you're like, oh, the quotient property. So yeah, there are some things in simplifying, definitely. And then were you guys checking or catching like maybe some chain rule mistakes, like when you had different things like integrals, or you have to show them? No, totally not. So it's good if you're finding your own mistakes, but you do want to kind of make a mental note of them, right? or put them in the when you see you think if something comes up with exponential or logs or with u sub, what to look out for. I do want to add one type of problem if it's not here. For those of you guys that are kind of chilling on this packet, can you take a second and peek? Were there any horizontal asymptotes or any limits to infinity with e's in this packet? Okay, then that's the type of problem we're actually going to add before we leave this packet, because exponential and logarithms, I think we'll put it on the front page. The AP loves to try to trick you with limits to infinity with horizontal asymptotes of exponential functions. We'll talk about it. For right now, though, hold on. Number 7, someone help me out. What did you think of doing to integrate?
Since it's constants, I didn't think of like FTC part 2 or anything. You just had to go straight into what if I brought that DT out, what do I get, and how can I use a use sub?
Okay. So Sean, what I heard him say was, what if I brought the dt out? Some of you, it might have been easier to think about this integral like this. That confuses you a little bit. If you bring out the dt, how many of you that helps a little bit? Okay. So this should make you think of what integral rule?
1 over u.
Okay. 1 over u, or technically, if it was a plus, you could almost do 1 over a squared plus u squared, but it would be nasty. There would need to be something else, because it would be a square root squared. But yeah, since it's not a squared plus u squared, then let's just make it u. Now, careful, when you do u, super common mistake. What do people not think of considering? The negative. Some people would jump to just doing ln of u, but I can't. It needs to be a negative. I'm not going to put my bounds, or if you do put your bounds, just to remember them, put little slashes through them. The AP graders, if it was an FRQ, couldn't grade anything that you slash through. But this might just remind you to keep going and actually solve the definite integral. But we can now say negative ln of absolute value of u, which is 1 minus t. Careful, guys. Real quick. I caught it on someone yesterday, and I honestly don't remember if it was AB or BC. I was finishing up the people who made up on Monday. Everything's ready for me to do final scoring. I just need to get the final scoring after running the Scantrons. But to write these bounds, if you have anti-derived, is it legal in any way, shape, or form to still have the integral? No. Some of you are trying to just remind yourself of the bounds, and you keep this in an integral until you plug in. But the dilemma is, if you have anti-derived, if you write the integral, this loses you the point, because the integral has been solved. So you cannot put an integral still there. It's like writing a limit after a limit has been taken. Sort of. It's actually a little bit worse than that. But it's like writing a limit after the limit has been taken. Once you anti-derive, the integral needs to be gone. How do I show my bounds? Right here, with a straight line or with a little bracket. With a straight line or with a little bracket. Now I go ahead and plug in. And I have negative ln of 1 minus e. Tyler, is this your mistake? Did you keep the negative and not distribute? I have no idea if this is the problem that you were doing, but that's possible. And then I have minus and negative, which will be plus ln of 1 minus 0.
This was, but also I forgot the absolute value.
Yeah, I figured I saw that too. I thought that would be both. What's ln of 1? 0. That's one of those ln things. Maybe some of you might want to go to the front of this packet and write down ln of 1 is 0. E to the 0 is 1. Maybe you want to write that down. It's not bad. This one, I get negative ln of 1 minus 1 plus e. Ln of e is 1, because ln of e are inverses of each other. Maybe you want to write down ln of e is 1, or ln of e to the x is x, whatever that little power is. If I don't have an x, I have a 1. So then, final answer is negative 1. I think. Double check me.
I
It was a double.
did minus
And then-
1, so I knew the 1s would cancel, but then I didn't do plus e, but then it rectified itself because of the absolute.
Oh, okay. So that was fine. Okay. Let's go ahead and go to the FRQs. How many did you guys have? Just, oh, you had 2 to do? Okay. So then number 1. What? This is a slope field. Why was it in this packet?
She was.
Why was it in this packet? It's okay. I'm just putting it right here, Zach. Thank you. Just to be fair. Okay. Why was it in this packet? Because how do you, well, I don't know. Did you guys get stuck on the differential equation part? Because this one was just kind of, after you get your slopes, you just followed the flow, right? Let me go down to the answer key. Okay. And D was where all the points are. Not all of them, but most of them, right? Because D, it's just like a boom, 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 boom. Like, ah. Okay. Because there was only 1 point on C. There was 3 points total on A and B, just drawing and then following the flow. So on letter D, okay, hold on, the wording. Solve the differential equation that goes through the point. Everybody. No, 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 no. Come on, we did a packet on this.
Separate your variables.
How? What did I tell you to do first? Multiply the dx. No pause. How do you separate?
Divide by 2 minus y.
Stop. How do you separate?
Oh, wait, you multiply dx.
Okay, one more time. How do you separate? Okay, what if it's a dt on the bottom? What are you going to do to separate? Okay, don't do anything else first unless your brain is like, no, I got this and I've gotten it right time and time and time and time and time and time again. Then you do you. But everybody else, when you need to separate, wait, when are we separating?
Every time it wants
To integrate. To solve a differential equation or to find a particular solution to a differential equation. Whenever they say find a particular solution, you can put it in quotes and take it to the bank. If it says solve the differential equation, you can write it down, put it in quotes, take it to the bank. Every time multiply by
for numbers. Dx.
separate by multiplying by.
Dx.
Got it. And as soon as you multiply by dx,
Dx.
who just got trapped?
Your y.
The 2 minus y. The whole thing just got trapped, didn't it? Because it was times the whole thing. So how do I do that? I got to get rid of it. It doesn't belong. Now it looks messy, but check it. I have 1 over 2 minus y dy equals the integral of 1 dx. That's the only legal way to separate to solve. It's okay, we're drilling it. So to solve the diffie q, to find the solution of the diffie q, multiply by dx. And if there's a y expression trapped, divide. Now, doesn't this look a lot like the one that we just did with u sub? U is equal to 2 minus y, du is equal to negative dy. There's going to be a negative when I do my ln of u, my ln of 2 minus y. And then this integral will be an x plus c. Let's go down and check. So they separated, integrated. Negative, because they did u sub step by step in their heads. Negative, ln of absolute value of u equals the integral of 1. Is x plus c. They called it c1. You guys are okay just to call it c. You guys are okay just to call it c. How'd they go from here to here? Tyler, question first.
Oh, I don't know. I might have done my math wrong, but I guess it's a general question. If you have like CE to something and you divide by negative, it would be negative c. That can cancel, right? It just becomes c again.
Yes. The only time that you can't just be absorbing stuff into C is if you have already solved for C and you should have just plugged it straight in, and then, like, say you haven't gotten y by itself yet. Like, say you pause right here and you solve for C. Then let's say that you should have plugged right back into C before getting y by itself, but you didn't plug in. I've seen people get y by itself and then absorb C's, so that they're doing all this math to the C's without actually having plugged in. Then you're in trouble. So if you establish it early and don't get it plugged in and start absorbing, you're in trouble. But otherwise, as long as you either get y by itself first, then find the C, plug straight in, or whether you establish early, meaning you go find the C early, plug it straight in, then solve for y, you'll be fine. You can do that whole absorbing thing at any point before or after. Here's the dilemma. How do you solve?
Could you print the next thing beside?
You can do two things. One thing, people who know log properties, couldn't this negative come up as a power? That's one thing. Or you could multiply both sides by a negative. That's another thing. Yes. Because you would distribute it, right? And when you distribute it, that can get absorbed in the C. I haven't solved for C yet. I don't have any number that should be in the C spot yet. So yeah, I can absorb it. I can absorb it. That's okay. And then we can go ahead and do e to the. Charlotte, if we did it your way, making it a power, you'd have 1 over 2 minus y equals. Over here, you would have to multiply and divide, which would be the same as a negative power. Because it'd be 1 over e to the x, which is the same thing as e to the negative x. Your c might be different, but what was your final equation?
I did.
That's okay. Just y.
2 minus y. I didn't simplify. No. I put 1 over 2 minus y equal. No.
Oh, you didn't solve. You didn't solve for y at all. Oh, okay. So see, then you don't know. So what did you get over here?
1 half e to the x plus 1.
Plus 1 up here?
Yeah.
Okay. So then if you were to multiply, you could get 2 over e to the x plus 1 equals 2 minus y, right? Then you could add the y and subtract. Remember what I was saying is that this is just going to have everything written, not negative exponents, but written this way instead. Then can we make this y equals 2 minus 2 e to the negative power in denominator? Because 1 over x is x to the negative 1. You can make the power a negative. So I can make the power a negative. And then look, negative x minus 1. You were fine. But you have to get y by itself, or else it's not fine. Doesn't have to look like this. Remember, just stick it to the man. You could have... That's totally fine. Yeah, totally fine. Because you're not going to see that anyway, right? You're just going to be taking the AP. Just you have to get y by itself somehow. But for the rest of you guys, when we were solving, we would have ended up with, I just erased it all. E to the negative x plus c equals 2 minus y. Then what do we do with the c when it's trapped in the exponent? Bring it down and multiply. Good. And then my plus or minus, the absolute value can get absorbed in the c with the plus or minus. I can go ahead and solve for y either by subtracting the 2, dividing by a negative, or adding the y and subtracting. Either way, you end up with y is equal to 2 minus c e to the negative x. Some of you might have done a plus c because you're absorbing the minus in. It's not totally bad because at some point you eventually have to plug in, oh no, I need a clue. How do I do the c? I need a clue, and the clue they give me, I have no idea, guys. I can't see it. What's the clue? So y is 0, x is negative 1. So then that would be 0 equals 2 minus c e. And then I subtract the 2, divide by a negative. 2 is equal to c e. C is equal to 2 over e. In order to finish this problem, you must plug in. Y is equal to 2 minus. Now check it. Are they going to take off if you write it like this? No. You don't have to get it to look like that. You don't even have to try. All you have to do is get the c plugged in, have y by itself, you're done. This is a version of sticking it to the man and not making it wrong by trying to fit some perfect answer key that you don't even have to match. You just have to be right. Does that make sense? Okay. That was FRQ number 1, or the first one that you guys had in the packet. Then FRQ number 3. The second one was fun?
Yeah. It's deer and wolves.
Deer and wolves. Ooh, that's exciting. 2 isn't even, but if you guys want to ask me about it later, that's totally fine. Okay, you guys are getting a feel for what's there, right? So we have D of t is number of deer, not rate, number. We have an initial for the d, so we know d of 0. There were 35 deer to begin with. Ooh, and then we know d of 2 is equal to 48. Also suppose that wolves were first spotted in the forest. Okay, so wolves first came. P.S. I think we should have time to look at it before the actual AP. It might just be one of the days that some of you guys are gone for the AP. For another AP, I should say. This is a lot like the banana problem from last year. Because the store opened and customers started buying bananas, and a worker didn't come on shift or didn't go to the job of restocking the bananas until a later time. It's like this. The wolves didn't show up until t equals 2. And that their population increased according to the logarithmic model. Ooh, increased. Okay. According to the logarithmic model. Letter A. Write an equation that models the population of deer in the forest for all time 0 to 10. Now, here's what's nasty of this one. And this is why I can tell that a teacher made this and not the actual AP, even though it's very similar to an AP question. They are making you make the equation yourself, and I have never seen the AP do that. However, exponential growth does show up, so let's go ahead and review real quick. They went ahead and used the equation y equals c e to the kt, and they were able to say, hey, when t is 0, what is y? 35. 0 is 1, so they know that c is 35. C, well, the y value is technically called b in this equation. 35 e to the k times t. Then it's like, well, who's k? Well, what else do they give you? Another point. So then you could have gone ahead and plugged in. You would have gotten your k to be ln of 48 over 35 divided by 2. Once you plug in your other clue of 48 equaling 35 e to the 2k, or k times 2. Struggle. Then you solve for k. You end up with, then you could go ahead and plug in. Now they went ahead and just called this k the constant, so technically this is simplified because they're like, hey, this guy is this guy. Cool, this is the equation. You could have also just plugged the decimal in. That was kind of silly they didn't do that. What other questions do you guys have, though? I just wanted to point that out in letter A. I have never seen them make you use like chem skills or exponential growth and decay skills. But B is where it got weird. It's weird to graph. Well, because your numbers are funny.
Well, it's not even that. It just takes a long time to graph because the calculator's slow.
Oh,
So
that
you get the
happens.
window wrong.
But pause. Nathan, you had a question on B?
Yeah.
Okay. If the model in part A was true for t equals -1, what would be the population? What would the population have been at t equals -1? All you had to do is just plug in t is -1 and solve. Yeah. And then letter C, this is the one that Tyler was just talking about. At what time was the number of deer equal to the number of wolves? Ooh, I did not like how they worded this question. That's okay, though. Just setting d of t equal to w of t. I don't like how they worded the w function as increased by. They should have said something like the population is modeled by. I don't like the wording that they used. But yeah, setting them equal to each other and solving. Guys, when you set them equal to each other and you're allowed to use your calculator, I need to make sure you can use your calculator, right? In using your calculator, what are the two different features? What are the two different options as far as solving? Intersect is one option. You can make y1 equal 2 and then y2 equal 2, right? One and then the other. What's the other way that you could actually do this on your calculator?
I don't know.
Okay, let me show you then. Because, no, I'm just warning you. If the numbers are big, it's going to take you forever to find the window as to where this intersects. What if it intersects when the... Sometimes. But sometimes I've seen ones where it's really hard and it, like you have to graph the whole thing before you can change the zoom and it gets really mad at you, etc. So another way of doing it besides the intersect feature is that you could, hopefully know how to use the intersect feature. If not, come on in, let me show you how to use your calculator. You could also take the d of t, which we solved right here, right? So that'd be 35 e to the 0.1579. Why do you think there's more than 3 decimal places?
Because that's just
It's not the final answer, right? It's just an in-between step. That's my D. Here's my W. My W is up above the 37 ln of t squared minus t.
There's a mistake in this question.
Cool. Is it in what I'm doing right this second? Okay, then I'll keep going. So if I was to go ahead and graph in the Zoom standard, which I have no idea it's 2.6009 years. It could be something like 20 years, and I'm not even close. But right now I'm like, okay, cool, there's one. That just got rough, right? I have to zoom and play with the window, yada, yada, yada. Okay, here's another way. The other way is that you could deselect these and be like, I don't care about them individually, okay? I don't care about them individually. What I care about is when they're equal to each other. And when they're equal to each other, pause. What would happen if I were to subtract the W on the other side? I could do y1 minus, I'm doing alpha trace, my cool shortcut, minus y2. And I could say I just care about the zeros of the combined subtraction. There's 1 0 at a negative time, and there's 1 0 at a positive time. This one says, hold on, are there any time intervals? 0 to 10. All I'm supposed to be looking at is 0 to 10. It says, at what time will the deer...
Misty, it's twice in that time.
Yeah, that's the interesting thing.
Because that's like 9.8 or something.
Wow, okay. I just need to change this whole FRQ, because that fails. There would be 2 times, not just 1. You guys saw 2 intersections also? There would be 2 different times. So the answer key is partially wrong. Go ahead and change yours with a colored pen or with your pencil and be like, no, there were 2 times, not just 1. But you would find the 0. Guys, remind me of how the 0 works. Left bound? Hey, oh no, I'm going to have to scroll and it takes forever on my calculator, right? You can type in a left bound. Like if you see tick marks 1 and 2, you can type in 2 and be like, hey, just go to 2. And it's like, oh, cool, I can do that. You can say, okay, go to 3, and you're like, okay, cool, I can do that.
Does it work if it's off the screen, though?
No, you have to be able to see it.
Yeah.
Sorry. For everything except for trace, I think if you do the value feature, it might give it to you as long as your x's are in the window. But there's the 2.60079, and then the other answer would be second trace, going to find the 0 one more time, because there should be 2 times, not just 1. What did you guys say? It's between 9 and 10, right? So 9 could be a left bound, 10 could be a left or right bound. Yeah, there truly were 2 times, 9.824. Whatever teacher made this did not go looking hard enough. And then letter D says, at what time was the rate of change of the deer population? Rate of change of the deer, isn't that D prime? Yeah. Equal to the rate of change of the wolf population. Isn't that W prime? So you would have to take D prime using e to the u times u prime. And this is that number, that 0.1579. And then W prime, you'd have to go ahead and solve with ln of u, 1 over u times u prime, 2t minus 1. That's what you see right there. Then couldn't you do the same? Now, guys, couldn't you set this equal to y1, this equal to y2, and try the intersect feature? Yes, but what else could you do based on what we just saw? You could answer the question. What else could you do based on what we just saw? Subtract d prime minus w prime equals 0, or similarly w prime minus d prime equals 0, and just use the 0 feature. Why is it nice? If you're looking for zeros, they'll always be right here around the x-axis. If you're looking for intersections, they could be way high or way low. So that's why this could be a good trick for finding it. Okay, Tyler, go ahead.
No, I was just going to ask, can you put like a dy dx in the function thing so you can do one minus the other?
You can't have the calculator solve for you an indefinite, general derivative. It can solve for you a specific derivative, which is very helpful at times. Just sadly, this FRQ hasn't asked for it. Neither have any of the ones that we've done recently. You can solve for a derivative at a point and not have to do it by hand if you're allowed to use your calculator, but you cannot use your calculator, sadly, to solve for the formula, which is what you need to plug into your grapher. Oh, scroll up on the answer? Yeah. There you go. Can you see it okay? Kiddos, while Nathan is looking at this answer key, I'm actually going to, Nathan, give me 1 second. At the end of each of these packets, have you guys noticed there's a last page? What's this last page saying? If you need more practice on this type of problem, hold on, eyes up here on the screen. At the end of each of your packets, there's this little burp-a-derp-a-derp Now, this technically, I think they made these LTF reviews probably around 2009, maybe? 2008, 2009, maybe 2010. So it doesn't necessarily keep going. You guys can actually, there are things by, I think it's Lynn McMullen is the name, and I can actually post it on your AP exam resources that actually list out FRQs by topic. Why would that be important? If you guys ever want to find FRQs to practice with, they have up on a public website every single FRQ that has been given in the last basically ever online with scoring guidelines. Starting with last year. You guys have heard me say multiple times, oh, interesting, where is last year? Huh. That's very interesting. Now I'm a little confused. Anyway, 2017 is missing. Anyway, they have FRQs from every past year where you can go and you can say, hey, 2016, like in this one, it was saying about 2002, 2005, Form B. There's a Form A, Form B, and international exam. There are lots of different APs given every year, kind of. But you can go and you can actually like say, hey, what were the FRQs that were given 2 years ago the kids had to face? You can actually look at the questions. You can come back. You can look at all the scoring guidelines. And you can actually see like the answer keys that I show you as far as the points. You can do something called Student Performance Q&A, which has to do with discussions as to, for the AP graders, what was the point of the question? What were they supposed to get? What were they supposed to do? How did students actually do? What were the most common errors on the exam, et cetera, et cetera? How did you grade those common errors? Scoring statistics, you can look and say, well, I did this well. I wonder what was going on as far as the mean, the average, and the standard deviation as far as for each of the kids that were taking the exam, et cetera. Oh, that's all it shows? There's a lot more details, but maybe it only shows you so much. You can try question 1 and be like, ew, I don't like question 1. I did the best I could. I wonder how other students did. And they'll give you not only the answer guideline, but hey, here's a kid who, it's like, no, but it's an actual person scanned in work. And they give you like a high, a middle, and a low. They give you like what question 1, sample 1A got a 9 out of 9. The second one got a 6 out of 9. The third one got a 3 out of 9. And they exactly tell you why they missed the points that they missed. So there is so much, there are so many details. There are FRQs after FRQs after FRQs. And hey, you can keep going because there are even ones before 1998 on a different page. Anyway, all that to say, if you guys do want to practice any of these topics more, this is a beginning point. This is a beginning point as far as finding more FRQs to do. What is your homework for tonight for tomorrow?